today. Can you hear me? Perfect. So I hear that you can hear me. That's great. So thanks for joining for our first speakers corner format. It's great to see you here after the morning discussion as well. Today we will have Ilya on the stage who will show you some tools that he are working with and that you could possibly use. And afterwards we will hear from Sad and Jakob about their projects that they already started on the platform. They will explain what they had in mind to work on, and you can ask questions and join them in the work. So unless there are any questions initially now to me, I would give the stage to Leah.
Hi everyone. I'm trying to share my screen. Can you see it?
Yeah.
Okay. That's a bit of an impro. I'm not really well prepared, but I'll just yeah, try to improvise. So I'm Ilya Boyandin. I am a data visualization developer at Unfolded, and I joined just recently, 2 months ago. But I've been doing some geo data visualization for quite a while. And Unfolded is a company based mostly in San Francisco, so I work remotely from Zurich. And we are trying to build a new generation geospatial analytics platform. And here you see a Swiss knife. It's no coincidence. So there are like many tools built into the platform for geodata visualizations. It looks a bit like this, but I will show some examples later. And you can do like very different kinds of geographic data visualizations with it. And mostly you can use it for free. It's just some advanced features which are not free. So the origins of the company is Uber. There was a big data visualization team at Uber. They were developing tools for mobility data analysis. But since it wasn't the core business for Uber, they just were using these tools for their internal data analysis. They open sourced them. And at some point, the core of the data visualization team left the company. And Uber, luckily, Uber even allowed them to really open source it. So now it's like the libraries and some of the tools behind Unfolded are part of the Linux Foundation, which is an independent organization governing open source projects. And like this part is called Urban Computing Foundation, and it's like an umbrella for multiple projects for focusing on urban computing and analysis of urban data and geographic data. So one of those projects is DeckGL, which is a library, JavaScript library for rendering geographic data visualizations in the browser using WebGL. That means that you can represent as like more data than with other techniques like Canvas or SVG in the browser. WebGL is the most powerful, but it's quite tricky to use, quite involved. And DeckGL is making it much easier to render some kind of geographic data in WebGL. And if you go to the documentation, there are many layers. You can basically add many layers to the map, and there are very different ones you could see heat map. There is 3D arcs. There is GeoJSON. You can load a geographic data set. In this case, it's lines. Or yeah, you can render hexagons. You can render tiles, vector tiles. You can render terrain, 3D terrain even. Yeah, or just like the simplest one is circles. You can have circles of varying size to represent some kind of values. It's can render hexagons. Yeah, you can build with React in mind, but it doesn't have to be used with React. You can just use it with plain JavaScript. And another library which is part of this WizGL suite is called React Map.jl, and it allows us to render originally mapbox background map, but actually now it supports more. It supports Google Maps as well, or it supports basically any vector tile provider supporting mapbox standard for the styles and the vector tiles, which includes Swiss Topo. They also released tiles in this format. Yes, another one, like these were development tools which required knowledge of JavaScript and programming. But Kepler.jl, which is part of this suite, is a tool for analysts, for people who don't need to know how to program. And it's a tool, open source tool, with which you can basically upload, not upload, it's a client side. You can just drag and drop a CSV file or GeoJSON file into the browser, and voila, you have it visualized in your browser directly. And you can change the visual variables to represent some kind of values in different ways. It supports different kinds of filtering. For instance, here you see earthquakes data, and you can filter by time. It can do some kind of aggregations, different kinds of aggregation. Here with hexagonal binning, for instance. And it really doesn't require. You don't need to know how to program. Here there is a short, simple demo. So if I have a CSV file, here I have one with all the public transport stops in Switzerland, I think. So I just dragged it into the browser, and here they are, 37,000 public transport stops. Yes, so this is Kepler.jl, an open source free tool running in the browser. And at Unfolded, we are developing a more advanced version of it called Unfolded Studio, which also allows to upload large data sets in the cloud. Then you have your account, you can have your map privately for you, or maps visualizations privately for you, or you can share them with other people, but they are password protected by default. And you can upload large data sets, and there is some backend which may perform some expensive computations on the data. And it has some more features compared to Kepler, and we are adding more. So here I have an example of data for the canton of Zurich. We have all the buildings colored by their types, and we have here, like, this data set has yeah, the buildings after 1950, they have a year, I think, somewhere. Right. So we created a filter by year, and so now we can see how the city developed over time. So we can see which buildings were added when, and so every single building, we have it for the whole canton of Zurich. So there are like 300,000 buildings here, and it's a bit sluggish, but it still works nicely. Here I uploaded the CSV file with all the public transport stops in Germany, and they are colored by the operator. And here there are 700,000 of them, and we can still interact with the map. So in Unfold Studio, we can also represent 3D objects. Like here I have a GeoJSON file with buildings in Melbourne, and they also have a property for the height. And now I have this nice 3D representation of the buildings. And yes, we are also working on adding cloud optimized GeoTIFF support. Part of the data released by Swisstopo is also cloud optimized GeoTIFF, COG. It's an acronym. I didn't have time to load it into the app, but I have here an example for the US. Here we see there was this Eagle Creek fire in 2017, and here we have this swap compare mode in which we compare two layers. One is in fall 2017 and another in summer 2017. So it's before the fire and after the fire. And the green shows the vegetation, and so you can compare basically and see the vegetation loss after the fire, which is quite a big fire. So that's unfolded. Another tool I wanted to show briefly is Floma Blue, which is my personal project, and it's also based on DeckGL, and it's a way to represent movements between geographic locations. So it's been used for various kinds of data sets, computers, bus and train, bicycle travels, and also international migration. And it's quite easy to use. It doesn't require programming either. So you just need to create copy Google spreadsheet, then fill it with some data. Here I have 3 sheets, one with metadata, one with the locations, and one with the flows. So I have here origin, destination, and number of people moving. Then I have to copy this URL, and I can paste it here and get the URL to my map. Yeah, and if I go there, I can I can see it in the map. So here we see the migrations between Swiss cantons, and it's also interactive. We can filter by different kinds. It's also 3D can be rotated, and we can animate the flows, which in some cases helps to see the arrow directions better. So yes, I have an example here for this Floma Blue supports, like by default, it uses Mapbox base map, but we can also use other providers who offer tiles in Mapbox format, and this comes actually from this one comes from Swiss Topo. So here on this Geo.Admin website, I have the link to the style, and I just copied this link and pasted it here. And so Floma Blue will work with Swiss Topo tiles, which are really gorgeous. So here we see the commuter flows in the whole Switzerland. Here I can, like, the tool supports automatic clustering. So when I zoom out, I will see a better summary with fewer locations and fewer arrows. But when I zoom in, it will expand, and I will see all the detail between all the Swiss communities. Yes, so that's what I wanted to show. That's pretty much it. I created this slides with the links to the tools. I will share them on Slack. Maybe Ilya can add them to the website of the hackathon. And yeah, if you have questions, I'm happy to take them. Victoria?
I just wanted to say thanks a lot for the input. It was quite inspiring. If there are any questions, you can write it down in the chat or raise your hands with one of the icons in the bottom of the screen if you click on the smiley, so that we can see if you would like to talk. And if there are no questions, then I would invite Ted as the next one on stage to present the project.
Hold on. Actually, I would like to ask a question. Can you guys hear me? Hey, can you guys hear me now?
Yes.
Okay. I'm not sure it's that with answering the questions we need to figure out. I think probably the best would be if just the speaker comes off the stage and comes towards the participants, then we can just have a group circle. So I'll just follow Ilya down. But I do want to say for my part, большое спасибо, отличная презентация, очень интересно, Ilya. and I do want to say, as someone who's your commuter flows project has been inspiring and well known in the open data community for a long time. You've obviously worked with Swiss Topo data. I wonder how much, for one of these projects like you've shown, how much money would you be prepared to spend on, high quality government map data? Or maybe just give us an anecdote. Have you spent some money ever on acquiring data for your projects?
No.
So the answer is zero?
I mean, I'm building tools, so which other people use, and they upload their data into the tools. And so I'm just trying to do my best to help them represent this data in the best possible way. But yeah, where the data comes from, yeah, it shouldn't really matter. So so far, like with Floma Blue in particular, I get support from Mapbox. Since it's an open source project, they have some support for open source projects. So they offer me free access to their map tiles.
So you're not running up huge credit card bills,
Not at all.
collecting data.
It's all free.
Okay.
So the like Floma Blue, it doesn't have a backend. It runs like it uses Google Sheets as the backend, right? The data is loaded directly from Google Sheets, and I'm thinking of developing, like, there are some limitations to it, how much data you can put in a Google spreadsheet. There are like 2 million cells you can have, not more, in one spreadsheet.
Sorry
So
to
I'm
interrupt,
actually...
guys. I just heard from the audience that people don't hear you, Ilya, because you are right next to the stage. So everyone's not gathering around us. So I would recommend that we just go to the audience so everyone can really stand around you.
Like here?
Just somewhere there. Yeah, it's perfect.
Like this? That's cool. I wish I could jump in this gather tool, but it's pretty cool. It adds some more socializing aspects to...
Yeah. No, thanks.
To Zoom.
Listen, that's. I think you've really answered my question. Maybe just as a quick follow-on for your personal projects, is there what would be the best way to support you?
Spread the word, I guess. Yeah.
Okay.
For now.
We'll do that.
I'm yeah. Yeah, currently I work on Floma Blue in my spare time, but I have some hopes to make a small commercial version of it in the future. But I cannot do it right now because I have some obligations to my previous company, where parts of this, like I have this non-competition agreement. So I have to wait for 1 year before I can do something commercial.
Cool.
But I mean, it's not a really... yeah, as long as people can use it, it's fine. But there are some limitations to the current approach. So how much data you can load, and so my hope is to improve on that side. But for that, some backend would be required, and I couldn't do it for free then. So then I will be looking for some something I could offer for a small fee, or just... Yeah. But as I said, I cannot do it in this year. It might be that we'll integrate some parts of it into, like, some flow mapping support into Unfolded Studio. But again, due to the competition agreement I had with my previous job, I cannot work on it in this year, personally. So that's the story. I was previously at Teralytics. Let's see, it's a company in Zurich focusing on mobility data analysis. So there we also used flow maps. Yeah, but we open sourced the library FlowMapJL for drawing flow maps, which was also based on DeckJL. And so this is the library which I used to build the Floma Blue. That's the story. Yeah.
I would have a maybe sort of random question. And now that you mentioned it, I was wondering, maybe you have a good answer to this. So what's the motivation for a company to open source certain software that they have developed?
I think there are different it depends. Yeah, I could say sometimes, like, one thing is it might actually help with marketing, right? You establish yourself in a certain area as a professional, as a and you build like a community around something you started, right? And then if this community grows, some people, like, it might also bring some customers to the company itself, right? And help to establish your brand. Yeah, so that's one kind of the motivation. Also, it can help attract talents, right? If people see that you're building something cool and it looks cool, it's like there are many. Yeah, there is some life in this project, and it will attract people who want to work with you. Also, sometimes you get contributions from yeah, other people or other companies, even competitors. Like in case of DeckGL, like there are contributions from Carto, from Esri, and they are kind of main competitors of Unfolded. Still, they are contributing to the library, and there is some exchange of yeah, I guess it's not a zero-sum game, right? So even competitors can help each other to succeed, but they find their own areas where they are best, right? And offer something which others don't. But it's like always a difficult thing to balance, I guess. How do you find this unique things which you can offer to your customers, which others don't? So, and for like that's more about DeckGL and Kepler. Like also for Uber, it was a no-brainer, I guess, because it's not their core business. They are not selling anything like this, right? They would, but yeah, it also obviously the people who work on it must have the must raise their voice and tell their company that they want to do that, because it takes more time, right? To open source something, you need to write some kind of documentation, you need to support it, and it takes resources away from the company. So it might take some time to persuade your managers to do that. But yeah, it's often not a big problem. They see advantages in that as well.
I see. Very interesting. Thanks.
That's what I can say. Yeah.
Do we have any other questions? All right, then I would suggest that we jump into the projects. Sed, would you like to start explaining us what you had in mind to work on?
Sure. Hi, everyone. The idea with the project I opened was basically to leverage the data which is available, which has been opened up to try to develop and like some kind of platform which will form as a basis for anything related to solar panel potentials at the different levels. So my interest in this was initiated by a paper. Actually, I stumbled upon last week, published by the EPFL, which basically did an estimate of the solar potential in the whole country using a combination of Swiss topo data, combining altitude maps, like building databases and so on, plus physical models and also some machine learning techniques to get some kind of overall value, and some uncertainty interval around that. Then now thanks to some tips to some colleagues here, I saw some also some tools that had already been developed by Swiss Topo or related parties, which basically also provided different estimates at the total country level, but also at the Gemeinde and for specific roofs actually. So they're very nice tools that I've put in the project wiki, where you can basically type an address and get potential for the energy production from photovoltaic panels on one specific roof or a combination. So that's great. So the idea is not to reinvent the wheel, but basically maybe make the estimation process more transparent, to basically show which assumptions are underpinning those values. Because if we compare two different studies, we can see so the paper I mentioned and the data which is provided by Swiss Topo, we can find a factor from 2 to 3. And I was quite interested to see actually, what is leading to that particular difference. Is it different data? Is it incomplete data? Is it like more optimistic assumptions on the efficiency of panels, or of the or taking different weather time periods to compute like an average illumination for a particular place. And it's quite difficult from just reading a paper or just accessing the user interface to actually get a feel for that. So my idea was to get the data from the different places. So on Swiss Topo we can actually extract data for every building in Switzerland, and the values for the solar potential as computed by the model which is described in Swiss Topo's own paper. Same for the EPFL paper. There's also like a list of buildings using the same ID with let's say another their own estimate per building. So I would like to make some comparison in terms of what is leading to this discrepancy. And at first glance, one can see that the assumption for the usability of the roofs are sometimes different for a specific address. Not all the buildings were covered in the EPFL study, and things like that. And what would be nice as well would be to upload some data from actual production from a certain solar installation and compare to the forecast or the expected production according to Model 1 or Model 2, to try to actually get a feel of how far off we actually are with those models, or what are basically the factors that will make expectations to make those expectations far from reality or not. So I got some sample solar data from a friend. So I was planning to use that to actually try to get some comparison. And in the end, if we can have a tool that at least in the first step, allows us to just put an address and extract, the different values from the different models, and compare it with, data that we could upload for a particular site, that would be actually a nice first thing. And the second aspect, which is a bit more involved, would be actually to try to recreate the models, the physical models, or physical models or models in general underpinning the expectation of each paper, to try actually to enable some playing around with the parameters or the assumptions to actually get a feel of the impact on the final number. And the number could be at the country level, at at the canton level, at the Gemeinde level, at a specific area on a map or a specific address. But that's of course a bit more involved because that would actually imply redoing part or all of the work done by Sistopo a couple of years ago. But yeah, for me that would be an interesting thing to try out. Yeah, so I'm not sure what else to cover. Yeah, so and I've put the links in the project wiki to all the relevant papers or sites or tools that I refer to now. So I don't know if anyone has questions or is maybe interested to join the effort.
On mute. Thanks a lot for sharing your thoughts. How about we go down from the stage and join the team so they can ask questions right away. So any questions or anyone would like to join the project right away?
I've just pasted the link to Sad's your DripDat page. I think you're doing a great job just getting the essential starting points on there in a collaborative document, really easy to edit. And I don't know if you saw that, we reached out to try to track down the source code of the Solardacher and found the link. That was mentioned on the GitHub discussion.
Yeah, so this is basically the source code for the user interface, which is quite nice if we want to try the API underpinning each number. I guess it would not be possible to get the actual source code of the model, right? This would be maybe a bit more involved.
Oh, it's described, I think, in a paper on the website of the
yeah, absolutely.
But yeah, it's a question we can put to them. Is there anything? It just makes me think. Is there anything particular you would like help with? I mean, are you happy to hack on this on your own, or is there something that you really you want support with?
Not in particular. I'm fine doing it alone. I'd be also very happy to have some general help if someone is interested in the topic to brainstorm or work together on specific tasks. But, open to everything. Maybe actually I would have one question for anyone who would know that. If anyone knows like a tool or a Python library that would allow the conversion between like the Swiss coordinate system that is used in those data sets, the LV95, and the like latitude, longitude kind of standards.
There are several tools available. I can drop you a link in the chat. There are even services for that. REST services.
Much.
But what's the format of this data? Do you know?
Of which data, the building data and stuff like that. That's in a GDB format. So I use the Fiona Python library to basically extract the information I need from there.
Yeah.
Just going to take the opportunity to share your project page, and just we'd love to see this kind of quick links to the data you're using. These are kind of inspirational resources, a paper and the calculator you mentioned. Some thoughts about applications and a couple of goals, as you mentioned. So now I can just I just comment on this after signing in, and yeah, and then there's a way to contact you through the discussion and your profile here. So if anybody else wants to get a project page set up like this, just click Start Project here on the bottom. Give it a title, post URL, just save it, and voila, we have a couple of projects already, and hope to see a few more by the end of the week. And yeah, just do approach me or Victoria if you have any questions about the platform.
Yeah, in the meantime, also we keep updating the resources page. So we just pasted the links from Ilya there. And if you have anything to add, you can also share directly under resources. It works very similar as to suggesting a project. If there are no other questions or comments, then we could move on to the next project insight from Jakob.
Okay, so can you all hear me? Excellent. I think I can't hear you even if you unmute yourself, right? It's sort of a unidirectional communication channel. Okay, so yeah, I can quickly present the project that I've started to work on. Sort of a disclaimer in the beginning. This is kind of an unusual crowd for me. This is not really my field. I'm coming from physics and did my PhD in computational neuroscience. But I saw this as an opportunity to learn something new, and hopefully also build something cool. And so I set up this project in a way that it should be possible to do something sort of working, or to produce something sort of working within the week. And yeah, so the concrete idea that I was following up on is already a project on GitHub, I think in the discussion part, that's sort of a spin-off of the lane count, which was to count pedestrian crossings. And I found this quite interesting. And in particular, I really do like this Swiss image 10 centimeter data set. So this was a nice opportunity to maybe look a bit more into this. And the approach that I'm taking is, or that I currently have in mind, sort of a supervised machine learning approach, where basically you would set up a classifier that receives an image patch and then tells you whether the category that you're interested in is actually contained within that patch. And if you train it with lots of examples of pedestrian crossings, then the hope is that it will be able to sort of tell you with high confidence whether there's a crossing in the patch that you provide or whether there's none. Of course, there are, I don't know, probably thousands of different ways to approach this project, starting from the data acquisition phase So where do I get my training data from? Then to how would you actually set up such a classifier? Do you only classify image patches, or are you actually interested in something like sort of image segmentation methods or bounding box methods? But as I said in the beginning, my goal was to build something within a week. So I tried to keep everything as simple as possible. And in particular, also the data acquisition phase, I chose a manual path where I basically just wrote a small Python script that scrapes the images for the area that one is currently interested in from the API. I forgot the exact name, something like I don't know, but from the from the API, gets the image data, and then sort of presents these images one by one, but in a way where you can sort of efficiently tag 100 by 100 pixels patches that contain the object of interest. Yeah, so that's sort of working, these two stages, which means that I can start producing training data for the classifier and then move on to sort of figuring out what kind of classifier might actually be useful. Obviously, I had convolutional networks in mind since they have proven quite efficient in image classification tasks. But yeah, none of that is set in stone. So I guess I will just start playing around once I have a data set that looks reasonable. And then we'll see where this leads. One thing that I'm trying to keep an eye on is to keep this rather general, to sort of, if in the future someone wants to detect other things than pedestrian crossings, they should basically be able to use the same pipeline, because otherwise it's maybe a bit overfitted to one particular goal that might not be too interesting in itself. Yeah. Unfortunately, I don't have any results to show, but hopefully by the end of the week, there will be something cool. Right, and the concrete goal that I set is count all the pedestrian crossings in Bern. Because I think for all of Switzerland, this might be a bit computationally intense for my laptop. Yeah, I think that's all I have to say for now. But I'm, of course, happy to discuss various aspects of this project. So I guess I should come down from the stage now, and so I'm able to talk to you again.
Perfect. Welcome back, and thanks for the quick input. Questions?
What is the stack that you expect to be using? Which machine learning framework?
So I was planning to use Torch, PyTorch to be specific, just because I have some experience with it. And so I've never looked into TensorFlow. But for every optimization that uses differentiable classifiers, one of these two seems to be the standard if you want to work from Python. But if you're asking me which particular model of these millions of models that are out there, sort of the architectures that are out there, then I'm still looking into that. I mean, it would be very cool now if one of you told me there's already an awesome architecture that is specifically optimized for extracting data from aerial photographs. then obviously I would like to use that one. But otherwise, I don't know. I will probably start by with an MLP and then work my way up to more complex architecture.
But I guess it would be a transfer learning approach where you use already a model, an existing image classification model, and then you try to modify the last layers.
Yeah, maybe. I'm not sure. Since I've never worked on really large scale data, I'm not too familiar with how flexible pre-trained models are, how well they actually transfer from the natural images that they are typically trained on. Let's say now to these aerial photographs, which certainly have a slightly different structure, to me at least visually, than what you typically see. But yeah, I will need to read up on that.
So just sharing your project page again. This is the XDetect project, yeah? Where you've started just working in a GitHub repository.
Yeah, exactly.
So you can see your summary goal, everything. I do have to ask, why Bern?
It's just because I live in Bern.
That's a great reason.
It seems like a natural choice.
Start local. Fantastic.
Exactly.
Some beautiful crossworks in Bern. So yeah.
Yeah. So I thought, also, I'm guessing the cities might be most challenging because there are a lot of crosswalks in all different kind of forms and conditions, because you have these shadows on top and so on.
Mm-hmm.
Yeah, so it will certainly be an interesting endeavor. What's cool about the data set is that you essentially have, unlimited data, basically. The only limit is the time you're willing to put in to extract the the corresponding labeled data set.
Which makes me ask, in addition to your kind of coding stack, you said TensorFlow. Are you thinking of hosting this project on? Do you need infrastructure to host a machine learning project?
So I'm not using TensorFlow, but I'm using Torch.
Mm-hmm.
Just a minor clarification.
Mm-hmm.
But so I don't know. It might turn out that at some point it's useful to have a GPU cluster somewhere that can train the model. But I don't know. I'm not sure whether we will reach the stage of needing really a lot of compute by the end of the week. To me, it seems like maybe I can actually run this locally.
We have exactly.
Of course, for example, sorry.
No, go ahead.
No, I just wanted to add, so, if this turns out to be interesting and turns out to be working, then if you want to sort of label all the crosswalks in all of Switzerland, then a bit more than my laptop is necessary.
Fair enough. You might just have to start with your local neighborhood in
exactly.
the 4 days remaining. Okay,
Yeah.
but it's I think it would be interesting if there was a good environment to collaborate on a project like this. So if you need some tips, if you're not already using something like Google has this collaboratory, which is quite popular. In some of our cividi projects, we've used the Renku platform, which is run by the ETH and University Consortia, datascience.ch. And then there's of course just a whole bunch of cloud providers where you can just rent a GPU box and install anything you want on it. So yeah, if that's definitely one roadblock we don't want to have in your way. Just keep us posted.
Okay, great, thanks. I mean, in terms of just collaborating with regards to code, GitHub is usually my platform of choice. But then when it comes to computing, I would need to look into one of those. Could you maybe post the links somewhere?
For sure, yeah.
Jacob, can you hear me? Your project just reminded me of an article I saw. I'll post it to the chat. It's like from Facebook. They have a mapping department, and they recently did some collaboration with Esri, I think, yeah, even on trying to extract data for OpenStreetMap from satellite images. So it might be somewhat related, and maybe you'll find some hints for tools which can be used for that. Yeah, I think they open sourced some stuff.
Awesome, thanks.
There was a recent article I can paste here quickly regarding how Facebook teamed up with some major artificial intelligence AI to extract points of interest from satellite imagery. I'll post in a couple of minutes here in the chat.
So in your experience, since I started working on this aerial photograph data set, how comparable are satellite images and this data set? I mean, I guess, is it really just a matter of resolution?
What you have here with Swiss topo data sets is their imagery resolution is 10. You have a spatial resolution of 10 centimeters, and this is quite high. You won't get that from civil public available satellite imagery. What you have as well with is what you have to take into consideration is the spectral information, which is RGB in the data sets delivered by Swiss Topo currently. They plan, I don't know if it's already updated, to also include infrared, etc. There's also an infrared channel on the airborne camera. So, but currently the Swiss image itself is a false color or a true color. No, it's a false color RGB atmospherically corrected product. What you also have, satellites have up to 265 spectral channels. So there you have more signal to extract and more capabilities. But most AI detection algorithms work with the RGB with visible light spectrum. The last one is the radiometric resolution. I think Swiss Topo is 8-bit, the product you have. There are also satellite imagery with 10 bits or 16 bits imagery encoding, which gives you a better signal to noise ratio. So in short, I think for pedestrian detection, it will work. There will be no big difference. It's going to be, if you apply existing models to trees or buildings, the high resolution might not work with existing models, trained models based on satellite imagery. Hope this helps.
Okay, thanks.
I think also the angle is different, right? Like satellite images are usually from above.
Yeah, the aerial imagery we have, the camera on board of the Swiss Top airplane has forward, backward, and nadir looking, downward looking imagery, but only the downward looking imagery is used here in this product, Swiss Image. Satellite imagery, it depends on the technology you actually use. Is it a space boon where you have a camera which has a swath which goes left, right, left, right, left, right very fast, or if you have a classical charge couple display which scans at the same time. But in most cases, the products you get, like Lancet or Sentinel, you have an applied correction for which is called auto-rectification, which flats out the effect of the swath. But of course, the pixel on the outside is bigger than the pixel on the nadir. But usually, in the products, the outside swath are cut off. But the big advantage of the aerial imagery is that you have a crisper image because you have less atmosphere between the airplane and the object than, for example, 800 kilometers of the Earth orbiting satellite. So you get better edge detection algorithm will work better on